Good day everyone, my name is Ribenting Flores and welcome back to my YouTube channel. For today, we will going to discuss about the integration by parts. And the objective of this video is that at the end of this video, the learners are able to integrate equations using integration by parts. But before that, let us first understand and define what is integration by parts. Integration by parts is also known as partial integration. It is a process that finds the integral of a product of a functions in terms of the integral of the product of the derivative and antiderivative. So, to better understand the definitions about integration by parts, let us give or understand more it in this given IBP formula here. IBP stands for integration by parts formula, which is the integral of u dv is equal to uv minus the integral of v du. So in choosing u and dv, we should consider these recommendations. In choosing u, it must something that becomes simpler when differentiated, so it is the derivative. And in choosing dv, choose something whose integrals is simple, so it is the antiderivative. So as you observe and remember the definitions about integration by parts, it said there that through integration by parts, it finds the integrals of the function in terms of the integrals of its derivative and antiderivative. So the definitions and the IBP formula given makes sense. So for us to apply those understanding with the help of our formula, let us evaluate these given examples. So first example, evaluate the integral of x cosine x dx. First, we should let our u as x and our du is equal to dx. Second one, we should let our dv as cosine x dx and our v is equal to sine x. Our u is x and the derivative of our u is dx. Our dv is cosine x dx and the integral of our dv is sine x, which is our b. So remember the given formula here. So we came up with the integral of u dv is equal to uv minus the integral of v du. Just substitute the given to our given formula. So we came up with the integral of x dx cosine dx is equal to x sine x minus the integral of sine x dx. And that would be equal to sine, again, and that would be equal to x sine x plus cosine x plus c. To evaluate the integral of x cosine x dx through integration by parts, we came up with the value of x sine x plus cosine x plus c. So another example, evaluate the integral of ln x dx. So we let our u as ln x and the derivative of our u, which is our du, is equal to 1 over x dx. And our dv is equal to dx and the integral of our dv, which is our v, and it will be equal to x. So remember the IBP formula or the integration by parts formula, which is the integral of u dv is equal to uv minus the integral of v du. So again, just substitute the given into our given formula. So we came up with the integral of ln x dx is equal to x ln x minus the integral of x 1 over x dx. So solve it. If we simplify it, we came up with this value x ln x minus the integral of dx. Since x multiplied by 1, it will become to x divided by x, so it will be the integral of dx, and that will be equal to x ln x minus x plus c. So if we evaluate the integral of ln x dx through integration by parts, we came up with x ln x minus x plus c. Next, evaluate the integrals of x squared e x dx. So we let u as x squared and our du as 2x. We let our dv as ex dx and our v is ex. Remember our IBP formula, which is the integral of u dv is equal to uv minus the integral of b du. And then the same process, just substitute the given into our given formula. So we came up with the integral of x squared ex dx minus x squared ex minus 2 and integral of x ex dx. And then we exclude the 2, so we came up with 2, the integral of x ex dx is equal to 2x ex e raised to the power of x minus 2 e raised to the power of x plus c, and that would be equal to x squared ex minus 2x e raised to the power of x plus 2 a raised to the power of x plus c. If we evaluate x, integral of x squared ex e raised to the power of x dx, and that will be equal to x squared ex minus 2x e raised to the power of x plus 2 e raised to the power of x plus c. And that will be all for today's video. Please do subscribe and click the notification bell for you to be updated. And again, I just want to give credits to our instructor, Sir Mateo Caneda, for the LM materials that I've used as my basis or reference in making this PowerPoint presentation. Thank you and God bless.